Namaste and a very, very good morning to all of you. I welcome you to my channel, The Outlier. In my last video, we saw how to take a frequency distribution table. Remember, a frequency distribution table is applicable for a categorical variable. So when you have a categorical variable like species here, as you can see here, I'm still working on the iris data set. When you have a categorical variable like species, you can take the count of a categorical variable. But what when you have scale variables? When you have scale variables, the best way to summarize the relationship between two or more scale variables would be through correlation. Correlation is a very, very powerful and a very important weapon in the hand of a data scientist, particularly when you want to look at relationship between two or more variables. At a time, correlation gives the relationship between two variables. So we are going to see how you can get the relationship between two variables using a simple function called as the core_of function. As you can see here, I am working on the iris data set, sepal length, sepal width, petal length, petal width. These first four variables are scale variables, and I intend to see what is the correlation what is the correlation among these variables. Now, to do this, what I can do is I'll have to recall, call the object name iris and pass a function which is known as a core_of function. A very simple function, iris.core_of. Now, once you apply this particular function, what you see is that it gives you a correlation table. In the row, you have got four variables that are present in the data set. And in the column as well, you have got four variables that are present in the data set. We have got sepal length, sepal width, petal length, and petal width, right? And the numbers that you see are nothing but the correlation values. And as you all know, correlation lies between -1 and +1. If the correlation value is exactly -1, it means that there's a perfect negative relationship between the two variables. On the other hand, if the correlation is exactly +1, it means that there's a there's a perfect positive relationship between the two variables. If the correlation is exactly 0, it means that there is no correlation between the two variables. We have to be very sensitive to one important fact, and that is correlation does not imply causation. Merely because two variables have a very strong correlation, it does not mean that one variable causes the other variable, right? There is no causation from one to the other, right? Let's look at this particular correlation table. The diagonal elements that you can see here will always be 1, because the diagonal elements report the correlation between the same two variables, sepal length and sepal length, right? So it will obviously be 1. But if you look at the off-diagonal elements, if you look at the upper triangle, this gives you the correlation between sepal length and sepal width. It says -0.11. So correlation tells you, remember, both the strength and the direction of the relationship. I repeat, correlation tells you the strength and the direction of the relationship. The negative sign here says that as one variable increases, the second variable comes down. So there is an inverse relationship between the two variables, right? And the magnitude of the relationship is 0.11, which is very low, right? Correlation, anything which is less than 0.5, we can say that it's a low correlation. Compare the relationship of sepal length and sepal width, which is very, very low, with that of the relationship between sepal length and petal width. It is 0.87, right? 0.87 is on the higher side, which basically means that there's a high positive relationship. There's a strong positive relationship between these two variables, that is sepal length and petal length, right? Which means that as one variable increases, the other also increases. As one comes down, the other also comes down. This is what we mean when we say that there is a positive relationship between the two variables. I also see a high number. I see a big number, which is 0.81, corresponding to sepal length and petal width, which is around 0.81, right? So it's on the higher side. Therefore, we can say that when it comes to sepal length and petal width, there is a strong positive relationship between these two variables. Like this, you can go on interpreting each and every number. This is the beauty behind how you can generate a correlation matrix using a simple function .COR_OF. You have to call the data set name, any data set that you use. Maybe you have your own file, which is in the local machine. You can just import that file. And you can just put a dot and run this particular function, COR_OF function, right? So this COR_OF function runs and gives you the correlation metrics for the entire data set. Now, if you have 60 to 70 different variables, you may not be interested in all, you may not be interested in the correlation for all these 60 to 70 variables. In that case, you can just pick up only the top 2 or 3 variables and look at the correlation for only the 2 or 3 variables that that make business sense to you. How do you subset the data set and look at the correlation for only 2 or 3 variables, right? Very simple. You can just copy this particular data set name, right? You can use square bracket for subsetting the data set. I have got, let's say I'm interested in only 2 variables, that is sepal length, right? I'll put a comma here, and sepal width, right? So I'm subsetting the data set. Instead of looking at the correlation table for all the 4 variables, I'm just interested in only 2 variables, right? I'll have to put a quote here. Right, variable names should be enclosed within quotes here. So this is my data set. Let me see whether I've done this right. Okay, there's a spelling mistake here. It is not. I've just missed out L here. So I've been able to subset only the top 2 variables, only the first 2 variables, that is sepal length and sepal width. Now, what I need to do is get a correlation value for these 2 variables only. So I can put a dot here and run the correlation method on it. Right? You can just get a, you'll get a simple 2x2 matrix here, which gives you the correlation values for sepal length and sepal width. The interpretation is the same. If you have a value which is close to 1, plus 1, right? Anything above 0.80, 0.85, you can just easily say that there's a strong positive relationship. Same thing with any value which is very close to -1, you can say that there is a strong negative relationship, right? The correlation value that I am getting here is minus. I have to be very careful with this minus. It means that there's a negative relationship between sepal length and sepal width. That's what we can infer from this. Also, the magnitude of the relationship 0.11 is is very, very low, right? So there is a weak negative relationship between these 2 variables. I'm not doing any significance testing and such things. I'm not extracted my p-value here. This is a video just to tell you how you can run a correlation function on the data set, how you can subset the data set, and if you want to run the correlation method only on the selected variables. So with this, I come to the end of today's video. I thank you very much for watching my videos. I request you to subscribe to my channel. I'll see you in my next video.